Well, it's time to go to the final speaker of this morning's session, and it's a pleasure to introduce Ciro Donalek, a good friend and collaborator. Ciro was a student, postdoc, staff scientist at Caltech, and he has now been upgraded to Chief Technology Officer and co-founder of Virtualytics. So Ciro, all yours.
Hey, hi, thank you, George. So thank you so much for this opportunity and really great talks so far. So AI has become more ubiquitous in our lives. So we rely on it for a wide variety of tasks, from what movie to watch next to life and death decisions, think about self-driving cars, legal system, and the other many fields mentioned so far by the other panelists. But today I will be focusing on how and why visualization is a crucial part of the XAI process, especially when it comes to explain results to key stakeholders that are often non-data savvy. So first, let me briefly introduce our company. Virtualytics was founded in 2016 as a spin-off from Caltech and JPL, based on over 10 years of research in AI and data visualization. Our vision is to enable anyone to transform their complex data into AI-driven visualizations coupled with natural language, so to explain what happened, why it happened, and what will happen in an intuitive way. Now, the video on the right shows our flagship product, VIP, and a series of 3D visualizations coupled with the insights in natural language. And moreover, users can collaborate in real time using their desktop or even in VR. Now, this is an overview of the traction we are getting. We work with many DoD branches, as you can tell from all the cool logos on the right, and private companies in verticals like life sciences, Industry 4.0, logistics, and many others, focusing on advanced data exploration, AI explainability, and predictive analytics. As an example, last year, we were selected to receive the Air Force Strategic Award as one of the 21 Big Bets tech startup. We also helped the Air Force in building COVID models for areas surrounding their bases that ended up being very effective. But also in that case, adoption was boosted by us being able to explain these predictions and how we got to them in a way that people in charge could easily understand and then trust. And by the way, today at 4:30 Pacific time, we will also have a biotech demo that will cover the work done with isoplexis in generating more robust insights around the proteomic connection. This work was also presented at a recent conference in genome biology and by their researchers, and also stated that our platform allows life sciences researchers to find insights in multi-omics data significantly faster than current workflow, and more importantly, also an easier way to share with non-domain experts. But now, enough about us. Let me frame the problem at a more higher level, starting with the very familiar 5 V's of big data. So first is volume, of course, then variety, meaning data comes in all forms, structured and unstructured, velocity, that refers to how fast data changes, veracity, meaning how reliable data is, and finally value, because it doesn't matter how many gazillion bytes of data is collected, it has value only if key insights can be extracted from it and explained. And companies have to deal with all of that and more. In fact, the crucial part is not data being big, but instead being complex. Already often represents complex systems like a network of sensors or genomic data that now come in all sources and formats, sparse, structured and unstructured, with often a need to be analyzed in real time. And moreover, in recent times, a growing need is taking over, be able to explain how results were achieved to a broader audience inside an organization. That's also the challenge we are finding with companies we work now. And that was actually not the case in the past. Because I remember when data science team worked in silos, only results came out of them, not many questions asked by the end users. And in fact, in my opinion, the two main goals in analytics now are extract actionable insights to make better and faster data-driven decisions, but especially explain how results from complex AI models were achieved. So just a brief recap of like why XAI. First of all, because it can actually increase AI adoption in industry, otherwise difficult if results cannot be easily understood or explained to people without a data science background. Moreover, now that AI is in all aspects of our life, as mentioned also in other talks, individuals have the right to know how decisions were made, especially if they severely affect their life. So the basic questions are why did the AI make this prediction and not something else? When the system succeeded and failed? And the main one, in my opinion, is how can I trust it? Because the ultimate goal for XAI, in my opinion, is to make complex insight easy to digest by everybody and communicated in an effective way. And the need for XAI has also been recently identified in the Gartner top 10 trends in data and analytics that basically has a #1 smarter, faster, and more responsible AI with focus on model transparency and trust to basically protect against the poor decisions. So now the question is, are companies or even research centers equipped to deal with these new data challenges? And my answer is not really, because that's because while data and needs have evolved, like BI tools and packages actually haven't, and are not able to cope anymore with the challenges that this new wave of data is raising, let alone with explainability. So bottom line, we need to reimagine the way we represent, analyze, and interact with data. So today, I'm addressing the problem from a visualization standpoint, trying to give guidance on how to best use it in XAI, since I believe it does play a huge role in it. So in the next few minutes, I will go through in more details on what I believe are the 3 pillars of modern data visualization tools, in particular, multidimensional support, AI-driven visualizations, and providing a collaborative environment. Now, let's see one by one. Okay, so first of all, standard 2D plots may not depict the full picture when visually exploring the data. So the distribution on the right is a clear example. In 3D, everyone can easily spot 8 clusters, even if I don't use any color, while the 2D projections are way more difficult to interpret and may show only 4 or 5 clusters to the trained eyes. But 3D needs also to be done right. Like even nowadays, 3D is still mainly relegated to tools that offer what I like to call fake 3D, because usually are orthographic projections with interaction that needs to be totally scripted. An example is the scatter plot on the right. It does encode sites as an additional dimension, but it's impossible to understand if a point is bigger because it's closer to you or because its value is actually bigger. That's why my first suggestion is to build visualization in a 3D native environment, even for example, using a game engine in the backend, like we actually do. That makes possible to provide a true realistic 3D with like a correct lighting, animation, and right perspective. Moreover, if your 3D is done right, it will buy more than just the Z-axis. It allows to encode additional dimensions that otherwise will suffer from occlusion in 2D and look like a giant blob of data points. For example, additional dimensions are, besides position and colors, are the ones related to appearance, like size, shape, texture, glow, halos, opacity. Then animation also plays a big role in understanding how data changes. And also we started to do research on sonification, where each data point has a different sound based on its value, and that can lead to interesting results. But we still need to be careful to not overwhelm users. So information, these additional dimensions need to be presented in the right way as well. Like as a shape, don't use as tesseract, like on the right. It just messes with your eyes, but I've seen applications doing that. A good way is usually to follow the principle of importance ordering, meaning encoding the most important information in the most effective way. And there are many studies on human perceptions for different dimensions that can be applied. Now, having a multidimensional platform also allows to build a more effective visualization and interaction, otherwise difficult in platforms that only support 2D or basic 3D. And you will notice that throughout the talk, I will also couple visualization and interaction. And in this case, network graphs are a great example. Like a study from Forrester, very recent, showed that they are the best way to store and analyze unstructured and heterogeneous data and to study relationship between entities. And it's also a clear-cut example of a plot that is 3D in nature. Just as a side note, why graphs are so important, this is an interesting infographic showing that it is now an estimated 80% of enterprise data cannot be displayed as row and columns, comes in different formats from email to video, audio, images, so on and so forth. And more importantly, it is indeed more difficult to manage, analyze, and protect with legacy solutions. Moreover, network graphs are great, can lead to powerful insight, but can also be hard to understand, even to data scientists. And that's where explainability using a natural language and proper interaction is a must-have when building a network graph tool. It's really the only way also to drive graph adoption. Now, we developed two novel methods to explain the graphs using a natural language. One we called identification tree, and basically constructs an iterative decision tree that predicts community membership based on nodes values. The other one we called RED, relative edge density, and analyzed how interconnected our community along individual features. And we will be presenting these models in more details shortly after this talk at noon Pacific time. So please join like the session after mine to learn more. So this is an example where users can actually select a target, the features that they want to be explained, and the two methods I just mentioned are used to explain what happens in each community with auto-labeling and this interaction to select, zoom, and drill down information. So, and another suggestion I can give is always to follow the visualization, the information visualization mantra, that is basically overview first, details, and then zoom on demand while building your applications. Moreover, data storytelling is now an integral part of the data process and is very closely related to explainability as well. So linking abstract data to physical objects can actually help explain results from complex machine learning models, placing them in a familiar context, especially if the end user is an operator and really needs to understand what's happening. So bottom right is a multiscale explanation where results are shown using basically an actual 3D engine, almost as a dashboard, where you click on one of the parts and it can launch models, explainability routines, and show plots related to it. While the top left is similar, but is a photogrammetry model that can be done only if in a real 3D environment, while bottom left is a globe with a view that can be drilled down to the maps. Now, we can also go beyond the dashboard. that actually recent reports show they are like in steep decline. So in this use case, we go from an annotated human body, zooming into the lung, and then the actual data, and then clicking on the lung, and we go to the actual data that explain the COVID model using geospatial and anomaly detection to pinpoint key areas of interest. So in this case, the anomalies are shown as a halo on a 3D globe, and then you can zoom in a 2D map. So keep in mind, why we do that, why I suggest doing that, it's because most people, especially if they don't have a background in data science, find always difficult to understand abstract data, sometimes even like scatter plots, but do much better when they can link them to something they can relate to. And also is a way to remember much better. Now, the second pillar is based on AI-driven visualizations. So video on the right shows a dimensionality reduction routine made easy. So a user could take any data set and find what features impact the target and find anomalies and clusters in a matter of minutes or even seconds. Then there is an AI engine that ranks the feature and builds a set of visualization for the users according to the problem in hand. And this is another way of visualize complex machine learning models and main drivers in an intuitive way, and also to provide not people that are not really data scientists a way to basically investigate by themselves the results and the models. Now, more in general, in my opinion, modern data visualization tools in support of the XAI and data analytics should indeed provide embedded, easy-to-use AI routines. Like in this, and in this case, it's essential to work in a multidisciplinary environment comprised of data scientists, engineers, and UX and UI and UX experts. Like UI, like also Anima pointed out, needs to be intuitive, tailored to different needs and levels of data and of data literacy. And also NLQ workflow can help as well, using a language close to the end users that can ask questions like, what are the most relevant proteins? And by the way, we are having a very interesting NLQ demo session at 12:30 PT. And yeah, so another advantage is that embedding easy to use AI routines also has the advantage for organization to tackle their complex data sets without waiting for data science teams to analyze it. This means not replacing data scientists, but empowering analysts with data science tools and actually building a bridge between the data science department and the rest of the organization. Now, the third pillar is to provide a collaborative environment. So during COVID, we all learned very well how crucial is to be able to work closely with people geographically dispersed. Like even this conference format is a clear example of how we heavily rely on these tools nowadays. So there are many different platforms that allow video conferences, but here I'm talking more about a full-blown data science collaborative environment where users can run analytics in real time, see the result, discuss the results. Think about it as a sort of like Google Docs on steroid, but for data analytics. So this can be done, of course, with any medium, desktop, mobile, but even in VR. And speaking about immersive environment, back at Caltech with George, we started working on immersive real-time collaboration already in 2007, using virtual worlds like Second Life or the open source version OpenSim. And we got a National Science Foundation grant to build MECA, the Meta Institute for Computational Astrophysics. George was the director. That lasted a few years and then evolved in a full-blown data visualization set. So that is now virtual edX. So top left is the handsome version of George discussing quasars with a colleague. Right, we have a Nobel laureate, John Mather, giving a talk. Then there is myself working freely at JPL. And bottom right, the Caltech campus replica that we built engaging students at Caltech. But things didn't always go as supposed. And every now and then we had some problems with rendering that still puzzles me years later. But then going ahead a few years, here an example of a collaborative environment in virtual reality where users can invite their colleagues and run routines in real time with very low latency. So immersive environments for collaboration do have many advantages. For example, I am Italian, I'm Southern Italian. Giving talks through Zoom for me is very frustrating because I speak with both my mouth, but also my hands. So, and in VR, I actually can do that, as also you can see. And it is also actually well shown that the proprioception, the sense of self and the others really do help in like having like more engaging communication through this medium. On the flip side of the coin, my experience is that vast majority of our clients prefer doing desktop to desktop collaboration. That's because VR still has some roadblocks to overcome. But lately, we have seen an increased interest in it, most likely due to COVID, plus the recent efforts from giants like Facebook and Microsoft. But in my opinion, it is a research very well worth doing it. As a scientist and as technologist, we always need to look at what will happen a few years down the road and be ready for it. Now, bottom line, when it comes to visualization in support of XAI, there is really no one size fits all. It all depends on what you want to give emphasis to. Your audience, like data scientists, not data scientists, half of a data scientist, mediums available, 2D, 3D, desktop, VR, mobile. But having the three pillars, multidimensional support, AI-driven visualization, and collaborative environments will go a long way. Now, let me just stress again how important it is to build a multidisciplinary team or collaborate in academia among different departments. So XAI really involves people with different skills and background. I can tell that it's also very exciting. I'm a data scientist, but I can tell that it's also very exciting. And I really feel blessed for my awesome team. We are over 50 now, each one of them with their unique skills. And like I would have never imagined how design could have, and UX could have such a big impact on understanding the complex models and the results and be able to explain them. And I'll stop here so we have more time for QA. Just a brief reminder to join us for the 3 upcoming poster and demo sessions, including at 4 p.m. Pacific time, the biotech one, where Akash Indurkya, our co-head of AI and Caltech alum, will show the work done with ISB as well, Institute of Systems Biology, and Jim Heath, another very well-known face at Caltech. And thank you.
Thank you, Ciro. The floor is open for questions for Ciro, if any. That XAI entails many different methods, some of which are applicable to data or put like saliency maps, and some are which are applicable to the models themselves, like LRP. Have you explored in detail how to create the visualizations of many different individual XAI methods? Ciro.
Yes, so this is another line of research that we are doing. I guess you mean like, so the focus today in this talk was more like about explaining results to end users, because it's a way where like XAI can really drive adoption of AI in the industry. And they're also having more trust, especially now that there are all these regulatory issues. But we are also on a side research, we are also investigating basically how to best explain results coming like from models like that can be interpreted, like random forest, or like from more black box models like neural networks. And I can probably write you some notes in the chat as well with some references. Cool. From Nelson, I've not seen any specific analysis focused on events mining. And it's not clear to me what you mean by event mining, unless it's referred to time series. And if that's the case, yeah, we have created visualization for time series, some that are more standard, like but in 3D, and some we are working on now that are more like exoteric, that basically to explain how data changes in time. And that's also where I believe animation plays a really, really huge role, because can let you understand, if done well with all the transition, can really let you understand how data or an event is evolved.
And let me just add that Ashish Mahabal will be giving a talk about time domain astronomy in this context in the afternoon. And also there'll be a poster in a poster session by Niharika Sravan, postdoc at Caltech, also dealing with this very subject. Okay, so let me put the links to the other Zoom sessions in the chat in case that you did not receive them. And here they are. So at this point, and if there are no further questions for Ciro, then I think we'll take a little break, and then I will see you at the virtual poster session. And then the main session will resume at 1 p.m. at this same Zoom link that you have received with your registration. Thank you.